Hello and welcome to a video that is going to look at graphs of rational functions. So you're looking at three rational functions, and we're going to basically describe the graphs in every way that we can, which is going to be describing the domain, the range, in interval notation. We're also going to be looking at x and y intercepts if they exist, and asymptotes, which would be vertical asymptotes and then either a horizontal or an oblique asymptote. You won't see both a horizontal and an oblique asymptote in the same problem because all non-vertical asymptotes, they describe end behavior, and there's only going to be one type of end behavior in any one rational function. Okay, so let's take a look at the first one. Now I wrote a couple notes underneath this one, and I sketched in the oblique asymptote, which you should be able to see if you're going to describe it. Okay, so in this particular problem, first of all, when we look at the domain, there is an implied, these vertical red lines, even though they're red instead of black, and you might think, well, the black lines are the asymptotes and the red ones are the curve. That's not necessarily the case. And in this first one, if you look closely, these are dotted lines and the vertical lines are asymptotes. So they're exclusions from the domain. They're not going to be in the domain. So when we mention the domain, which is part A, we have to mention everything on both sides and between the asymptotes, those vertical asymptotes, but not including the asymptotes. So we're going to say the domain is going to be everything from negative infinity to that first vertical asymptote at -2. And we're not going to include the -2 because that's an asymptote. It's going to approach but not cross that vertical line. Unioned with everything that's in between, that sort of cubic-looking shaped curve in between. That's a U for union, so let's just use a little uppercase U. So from -2 to +3. And then the rest of the domain will be from 3 to infinity. And again, we're using interval notation, so we want to use those parentheses as a way of excluding the -2 and the 3. All right, next part of the question is to find the range. Now, because of the middle piece, the range is clearly going to go up and down forever, so the range is just all real numbers. So we'll just say negative infinity to infinity. Okay, the intercepts. Now, if we look at the graph, we can see that there's an intercept, an x-intercept here, and there's another one here, and it looks like there's another one here. And the one in the middle is also a y-intercept. So that's it. So the x-intercepts are going to be at negative, so let's say x-intercepts at -4, 0, and +4. And then a y-intercept is also at 0. Okay, vertical asymptotes, if they exist. So the vertical asymptotes, we want those in the form of an equation of a line. So an asymptote is a line, and if we're going to say it's a line, we want to say it as an equation. So all these vertical lines are going to be x equals. So the vertical asymptote here, this one, is just x equals -2. In fact, the vertical asymptotes correspond with the exclusions from the domain, unless there's a hole, which we don't have here. So this is going to be x equals -2, and then there's another vertical asymptote at x equals +3. Okay, let's keep going here. The E is the horizontal asymptote if it exists, so there's no horizontal asymptote in this one because there's an oblique asymptote. We'll just use HA for horizontal asymptote. And F, the oblique asymptote, and we have here some information about it just to make sure it's easy to read. You won't always be given this kind of information, but you should either be given or be able to see it on the graph. But we have a y-intercept of 0 and a slope of -1/4. So this would just be the equation y equals -1/4 x plus 0, and we don't need to put that in. Okay, that's the first one. Let's try analyzing the second graph. Okay, so here we have the domain is everything except for one vertical asymptote this time. So I'm going to have you pause the video and see if you can find these answers. Okay, so we're looking at a domain based on the one exclusion, not having 2, which is a vertical asymptote. A range, now we have to assume that this this curve is approaching the x-axis, which is the equation y equals 0, and that's 0 is the only exclusion from the range. So we are taking 0 out of the range. There's no x-intercept on this graph, but there is a y-intercept, and we have to estimate this one. So it looks like it's pretty close to negative 1.5 right there. There is a vertical asymptote. That's just the equation of this line at x equals 2. There's a horizontal asymptote. That's the equation of the x-axis, which is y equals 0. And there's no oblique asymptote. Okay, now in the third one, you can just think of this this dotted line right here. Just think of that as a typo. Okay, it's not really part of the graph. It says that it's an oblique asymptote, but it doesn't look like one if you look at the graph. It doesn't look like the curve is approaching that line, so it doesn't look like end behavior. So we're going to go with the one that's drawn in there, and the statement underneath that says that it has a y-intercept. This is a y-intercept of 1 and a slope of 1/3. And going with that information, go ahead and pause the video and try to answer these questions. Okay, so there's the next one, and nothing really tricky or surprising in this. Just be careful. In this case, you don't have, like you did in example 1, that middle branch, that cubic-looking branch that tells you in a very easy glance that the range is all real numbers. But in this case, we don't really need that because we can look at the range and we can see that there's really nothing that's missed in the range, and it's really because of that oblique asymptote that there's no way for anything to be missed, because over here it's going to approach going above anything that you might imagine, and then here it's going to approach going below, and there's really just not any gaps. Okay, let's look at the next three. Same question, and why don't we do the same thing and pause the video, and there's just slightly different problems, and just see how you guys do. Okay, so there's the description of this graph, and let's just go on and try number 2. Okay, let's try the third one. Take a look at the second one, pause your video, and try the last one here. Okay, so this one was a little bit rough because some of the things you can't quite tell exactly on the graph, but I did my best here, so hopefully you guys get something close, and then the dilemma and the ones that I have asterisks will make a little bit of sense to you. So the domain is pretty clear-cut, I think, because there's just one vertical asymptote. The range, however, if you look, and just kind of let's look right here and see where do you think the lowest y value is on that. It looks like it's just a little bit below the x-axis, and it also looks like there's something happening here where maybe it's crossing here and here, and somewhere in between there's a minimum that's right below. So I just kind of went with that and made my best estimate. This would not be a good test question, but I have here a negative 0.1 to infinity for that part of the range, negative 0.1. And looking here, I just said it looks like it goes up to negative 3. You could easily say that's also 3.1. It's really kind of a tough call. So I just put negative 3 there. So the range is very iffy, more than one possible answer, just depending how accurately you're trying to read the graph and knowing that you can't read it 100% accurately anyway. And then the same thing happens with the x-intercepts. I put there's those 2 points there that I think look like x-intercepts, but that might be something that you might not agree with, and so you might have negative 1 or something like that. And like I said, that would not be a good test question, but it's at least good to think about a little bit. Okay, the rest of this is pretty much as you see it, not much options there. I do want to contrast this to the example right above, because here it was kind of a no-brainer to say, yeah, the range is all real numbers. And if you look at this with a ruler and you try to say, okay, I'm going to keep moving the ruler down and see if there's any place where there's not a part of the graph, and there's really no gaps. There's nothing that even comes close to making me think there could be a gap. Okay, but here, when I do that same thing and I move the ruler down, I'm like, well, there's a gap. There's definitely no y values there. So there's some kind of gap here in the range, and we have to at least acknowledge that with something in our answer. Okay, I hope you found this video helpful.